Okay, these are the Mod 16 Part 1 notes. This is page 1 and only. So a single page here, a single example. Same with the homework. The homework is one problem. Reason is this is a continuation of what we did in Module 15. Sorry, can you tell I'm trying to get the hair off the iPad? With formulas just looking a little different. So we are taking a look at the sampling distribution of the difference between two proportions. So we are doing a hypothesis test for two different sample proportions, okay? And so we've got some stuff that looks familiar. We have got our sample proportions. P sub 1 hat is the sample proportion for our sample 1. And P sub 2 hat is the sample proportion for sample 2. And then we also have just a P hat. This is the pooled proportion. So we are taking a look at everybody that we sampled in both groups. We have a pooled standard deviation. Again, the standard deviation of that pooled proportion. Notice here we don't just divide by a single sample or a combination of the sample size. This is very specific. 1 over the sample size for, the sample size for sample 1 plus 1 over the sample size for sample 2. Note that this is not the same as if we would have added them together. So be very careful when you're calculating that. And then our z-score, the difference between the two populations divided by our standard deviation. So a little different than what we've looked at in the past, but mostly the same, okay? So here's what we've got. We've got clinical trials of Nasonex. 3,684 adult and adolescent allergy patients were randomly divided into two groups. Patients in group 1, our experimental group, received 2 milligrams of Nasonex, while the patients in group 2, which is our control group, received a placebo. Of the 2,013 patients in the experimental group, so this is my P1 hat, right? So let's see if we can. Group 1 is our experimental group. And here's the information that we need for our sample proportion. We have 2,013 patients, 547. I realize I got really distracted mid-reading of the problem, so right now you might want to pause and go through and read that whole thing. I get a 0.272. We also have a control group. So we had 1,670 patients in the control group with 368 reporting headaches. So 368 over 1,671, and I get 0.22. Now, remember, we're using proportions, so we will be using a z-score. For those of you that it's making crazy that I wasn't consistent here, there you go. We want to know if there's significant evidence to conclude that the proportion of Nasonex users who experience headaches as a side effect is greater than the control group. So a couple of things that we want to make sure we highlight here. So we want to see if our P sub 1 hat is significantly larger than the P sub 2 hat, and we have an alpha equal 0.05 level of significance. So first thing I'm going to do is find p hat. Sometimes you see it as p hat with an asterisk. And here we've got our two, oops. We are taking a look at everybody that exhibited headaches as a symptom over everybody combined in both samples. Here I get 915 divided by 3684. I get a 0.248. So that's going to act kind of as our whole population. Our standard deviation here, which we've got up above. So I'm not going to rewrite that formula. I am going to fill in the numbers. So my pooled proportion, we got 0.248. 1 minus that pooled proportion. So 1 minus the 0.248 is 0.752 times 1 over 2013 plus 1 over 1671. And I'm going to extend my square root, so everything that should be underneath is underneath. I get a standard deviation here of 0.01429, and I'm going to go to 5 places for now. Okay. So let's see if we can figure out what we've got going on here. I've got a right tail test. We're talking about greater than. I want to figure out whether or not that P1 hat lies up there in the top very 5% of my curve. Okay. So here's my null hypothesis. That P1 equals P2. Notice we're talking about these as population proportions. We don't include the hat. My alternative hypothesis is that the proportion for sample 1, P1, is actually larger than P2. Okay, now, sometimes you may see this as P sub 1 minus P sub 2 equals 0. That just means there is no difference. And then our alternate would be that difference is greater than 0. P1 minus P2 greater than 0. So both of those say the same thing. Okay, now, I am going to use the critical value method here, which means I am going to start by figuring out what my Z criteria is, my critical value. And that's 1 minus norm dot inverse. Remember, we use norm dot inverse when we have a percentage, a proportion. I got 0.95. I'll back up just a second here. I was trying to cram stuff into the little corner and I shortened the command here. So I got equals 1 minus, not 1 minus, norm dot S dot inverse of 0.95. Okay, so we want the area to the left to be 0.95, which means the area to the right is that 0.05, right? So here is my 1 minus 0.05, which gives me a 0.95. We use norm.s.inverse when we have the probability and we want the z-score. So my critical value here is 1.645. Should be positive. It's more than that center. Okay. So anything that falls in here right? This is our rejection region. Okay. So we need a z-score. And I am going to rewrite this even though that is exactly the same as what is up here. I get a 0.272 minus 0.22. Notice here, we use that pool proportion to find the standard deviation, but as we subtract, it's our two samples that we are comparing. I get 3.389. Which, as a critical value, lies way up here, right? So that says we are going to reject H naught. If we have this and we want the p-value, to find p-value, which is the probability that something this extreme happens, I want a greater than scenario. So I could go equals 1 minus norm.s.dis, because I already have that z-score. I get 3.63891. I get a p-value of 0.00014. That's less than our alpha of 0.05. So again, we reject H naught. So up here, we had Z data greater than Z criteria, or critical value. So we reject H naught. And understand that Z data, that test statistic of 3.6389, gives us that really small p-value. It's that much higher than our cutoff score there. Okay, so let's talk about this. We're going to reject H naught. There is sufficient evidence at the alpha equals 0.05 level of significance to suggest, again, we never state anything, Nasonex users experience more headaches than non-Nasonex users. And there you go.